Electrical circuits are everywhere in our daily lives. They control the lights in our homes, the devices we rely on, and the security systems that protect important places. Understanding how currents and voltages move through a circuit allows engineers to design safe and efficient systems. In our scenario, a high-security bank vault is protected by a complex electronic circuit. To access the vault, the spies must navigate the circuit carefully, calculating the currents and voltages to avoid triggering alarms. This real-world application shows how circuit analysis isn't just theory. It can be the key to controlling and securing critical systems.
Control, there seems to be a lock. I can't get it open. How do I proceed?
For the setup of our circuit problem, we defined the following variables using the provided visual and Kirchhoff's voltage and current laws. We defined IA to be the current through resistor 1, IB to be the current through resistor 3, and IC to be the current through resistor 2. Additionally, using Ohm's law, V equals IR, we determined V1, V2, and V3 with their respective resistors and currents, V equals IR again. Additionally, for our final solution of power, we used the equation P equals I squared R, which is power equals current squared times resistance.
Here is a diagram of the electrical current with defined values aligning with Ohm's law, which is V equals IR. In order to solve this problem, we're going to need three equations, one for each of the variables. For the first equation, we're going to write our equation in the direction of the red loop. This is for the left side of the circuit. These values are going to be positive because they're going on the positive end of the battery and charge first, indicating that they're flowing with the current. In order to solve this problem, we're going to need three equations, one for each of the variables. For the first equation, we're going to write our equation in the direction of the red loop. This is for the left side of the circuit. These values are going to be positive because they're going on the positive end of the battery and charge first, indicating that they're flowing with the current. The opposite is said for the other side because they are going through the negative side of the battery first, meaning the values will be negative. For the third equation, we made the assumption that IC is moving upwards, meaning that IA and IC will funnel into IB, indicating that IA plus IC is going to equal IB. These are our three equations. Next, we will just plug in our values.
After simplifying the three equations, this is what we have. Using these three equations, we can solve for IA, IB, and IC. First, let's set up a system of equations to make it easier to work with. The first thing I'll do is combine these two equations by substituting one into the other. After simplifying, we get the equation being underlined here in red. Next, let's solve for IA. To do that, I'll rearrange the equation. I'm going to subtract 8,200 by both sides, then divide everything by 6,200. That gives us the value of IA shown here. Now that we know IA, we can substitute it back into the second equation. This reduces it down into just one unknown variable, making it simple to solve for IB. After solving, we find that IB is about negative 0.0003887 ampere.
Since we now have an official value for IB, we can plug it into this equation for IA to find its own value in amperes.
After getting our IB and IA values, it's pretty straightforward. In order to get IC, all you have to do is subtract IA from IB, and you're left with IC equals 0.0001457 amperes. After doing this, we are left with IA equals negative 5.344 times 10 to the negative 4 amperes, IB negative 3.887 times 10 to the negative 4 amperes, and IC 1.57 times 10 to the negative 4 amperes.
Using the equation P equals I squared R and the values of IB and R3, we get a power across resistor 3 as 1.239 times 10 to the negative 3 watts.
Now, in order to verify, we can plug solved values into the original KVL and KCL equations for A. For B, we can perform the system of equations again, solving for the variables in different order. And C, ensure solved values make logical sense.
You got it.
Oh my gosh.
Delta, you're clear.